Hello everybody, welcome to EPG Pathshala. I am Shubhashish Bandyopadhyay, Associate Professor of IIST Shibpur, and I'll be delivering a talk on computer application in quantitative analysis. This is part of research methodology module. Whenever we use computer for a specific purpose, we would like to enhance the outcome and try to systematize the thing so that our work can be redone, stored, retrieved, and can be put to effective use time and again. There is also scope of development of the tools and approaches over time with enhancement in sophistry of mathematical issues and calculations involved in the process. However, all this quantitative aspect of the analysis in the best of the computer still remains an aid in sociological research. So it cannot by any means replace sociological understanding of the issues that affect us, issues with which we feel perturbed, with issues with which engage requires theoretical understanding, practical orientation, and a feeling of embeddedness. Without these things, any application, how much sophisticated it may be, is actually of very little use. So, computer application of quantitative data analysis is a very important but a tool in hand to develop the generalization and the possibility of usages of any sociological perspective. In this context, the issues are software generation, the input process, and the theory and quantity connected through a qualitative measurement. That means, though we are talking about quantitative application, these quantitative applications of computer in sociological research actually contribute in enhancing the quality and the girth of the research. So, overall, we may say that computer application in quantitative analysis is a very important and substantial tool to increase the acceptability and generalizability of sociological analysis and interpretation. Quantitative analysis in computer application requires software interface. This software helps us to make the things objective, generalized, and help us to connect the objectivity and generalization with theoretical interpretation. So, formalization of the tool takes place through a computer mechanism where the underlying logic is supported by mathematical process. Algorithm, software, programming, and language development takes place only to help us to substantially increase the generalizability and lessening the subjectivity of the researcher from the researched. But at the same time, with the help of objectivity and generalizability, the sociological researcher tries to achieve an interconnectedness with the theoretical understanding of the problem they are trying to deal with. So overall, it's a complete package of objective analysis and generalizability with a theoretical construction in mind. The formalization is important because it helps in reducing the subjective interpretation and any kind of bias that may affect the outcome of any research process. In computer application based quantitative research, there are the issue of selecting of research design. In sociological research method, the standard segregation is between descriptive, analytical, experimental, exploratory, and quasi-experimental research design. There are distinctive differences within these approaches, but each of them are unique in the way they approach the specific problem in a specific perspective. Say, for example, descriptive research is loaded with analysis of the situation through description. Their data are cited as self-explanatory thing, whereas while doing explanatory research, there is a need of a tentative proposition where variables are interconnected, and this interconnectedness is given a vector with a direction to analyze it further to arrive at a meaningful orientation towards the problem. So, explanatory research normally starts with some kind of a proposition and generally ends with a testable hypothesis. Sometimes the hypothesis may also test an existing theory. In exploratory research design, however, we use quantitative data only to substantiate certain newness of the fact, where hardly any theoretical framework or any quantitative model exists. Everything that is generated is new here and can open the thing and the perspective for future explanation. Most of the exploratory research ends with a proposed hypothesis. So this kind of distinction helps us to locate the appropriate technique that has to be used to formalize the approach towards data structure generation, information flow, and interpretation within a given perspective. Quantitative data analysis in research is the most common way to maneuver within the complex data matrix and to arrive at a very generalized but sleek and smart conclusion. It helps in reducing the subjective bias formalized within the available resources, make the sequence structured, and helps us in representing the descriptions of the reality in a sleek and smart way. So, quantitative technique is sophisticated as an analytical tool and very important for generalization and objectivity, but at the same time it is also very attractive if you have a basic grip over the issue and try to replicate the thing time and again for its reliability and validity. Therefore, quantification is not a hard thing to emulate. It can be reproduced many times in many different situations with the same kind of objective. The most important aspect is that you can store and retrieve the data and reanalyze the data sequentially wherever the situation demands such sort of repetitive experimentations and calibration. So overall, this way, computer helps us to apply quantitative understanding of the reality in a very user-friendly manner for a broad spectrum of users. Most of the quantitative research in survey-based studies, in content analysis, and in explanatory mode, we start with a hypothesis. Hypothesis is generated from interconnected concepts, where one set of concepts are dependent variable and a separate set of concepts are independent variable. There is a cause and effect correlation between these two sets of variable. They generate a statement of proposition, and when we put the proposition into test, we get hypothesis. The hypotheses are of two types. One is alternative hypothesis, we call it H1, and the other is null hypothesis, we call it H0. Keep it in mind that H1 has to be complemented with H0. Without having that complementarity, we cannot test the H1 against any viable alternative. That means in a given case, the H1 has two possibilities. Either this may come out to be true or this may come out to be false. If it comes out to be true, then HO, which is originally thought as a null hypothesis, is rejected. Simple. But alternatively, if the H1 is rejected, then you have to redo a bit of research to see whether the null hypothesis can be put into a pedestal of acceptance. So, in a parametric and probabilistic way, the H1 H0 combination is a good way to test the feasibility of a project and its possible outcome in a given space and time. Therefore, it is important that we also understand from hypothesis we get the issues and the reflections on the concepts involved, and the concepts are connected through a theoretical loop. So hypothesis is not taking place just in quantitative front but also directly connects with the quality of the research matrix. In quantitative analysis, social quantities are important factors which should be counted for its variety and versatility. Say for example, if social quantities are not measured, then we cannot get any kind of numerical outcome of a thing, of a situation. Say the rate of childbirth, the death rate, the density of population, all these things are social quantities. But more importantly, the more interesting social quantities are necessary labor time, age distribution, and gross domestic product in an economy. All these things are relevant just not as a number, but also reflect on numerous other possibilities and opportunities and obstacles in the process involved within the dynamics of socio-cultural, socio-economic, and socio-psychological parameters. Quantitative analysis, we use different kind of scale of measurement. For example, nominal scale, where there is no ranking or a time-based ordering. Then we have ordinal scale, where there is a rank-based ordering. And there is interval scale, when the rank-based ordering takes shape in a group of frequencies. For example, gender, religion, all these things are attributes of certain group of people. These are nominal scales. Ordinal scales having a kind of order, say high or low. Interval scales have their interfaces in a specific attribute. Say for example, the age group of 17 and 19 has a kind of same interval with age group of 87 and 89. This sort of ordering is necessary to codify and to systematically distribute the population and the sample with the given parameter to understand the generic nature, the specific nature, and the unique nature of the population and the relevant concepts involved within the specific area of study. Through this scale of measurement, the nominal, ordinal, and interval, we try to operationalize a concept. If we do not operationalize a concept, we cannot really arrive at a calculability of the numerical understanding of the concepts involved, and we cannot convert into numbers, and it is important that we operationalize a concept so that the numerical strength of the concept remains uniform, distributed evenly, and show some kind of robustness while depicting the original issue which is to be discussed or researched upon. So operationalization is an important tool for transformation of a qualitative scenario into a quantitative one. Without that transformation, we cannot measure the degree, the girth, the intensity of the situation in a mathematically expressible and computationally understandable matrix. The operationalization leads us to strategic measurement techniques. That means whenever I try to incorporate certain amount of analytical tool within the available resources, I have to think that what is the measure of association, what is the measure of proximity, what is the strength of the bondage between various variables. Accordingly, we program our computer and generate our own software to actually understand the strength of association and strength of intensity and density within a population structure. Therefore, it is important first to understand from where to approach the problem with more numerical prospects and where to approach the problem with qualitative analysis. Accordingly, we start understanding the use of parametric and non-parametric approaches, probabilistic and non-probabilistic approaches, and try to implement this formulation within a computer program. The program may be already available, the program may have to be created. The best way is to generate one's own program to replicate and depict the uniqueness of the sociological analysis in a specific case of research problem. Significance of association is an important attribute in quantitative analysis. We have to understand that not every problem is amenable to significant understanding of its association with other problems which are affecting our life. Say, for example, a flood may regionally increase the rate of death in a region. A drought or an earthquake may same way affect the population. But this has nothing to do with the generic nature and regular pattern of the birth rate and death rate in a given locality over a long period of time. So accordingly, we have to fix our priority to understand the nature of significance of the data structure and how to associate them in probabilistic or non-probabilistic structure. In descriptive statistics, we normally start with central tendencies, skewness and kurtosis, distributions, and standard deviation and variance test. Sometimes we complement this with more kind of generic t-test and z-test of a distribution. But the essential task is to arrive at a position of normal curve distribution where data is distributed in a sequence within a normal range of limit. There, the dispersion is measured in terms of the deviation from the central tendencies where the mu or the mean, median and the mode converge at a level of 0. The point is that the significance is that how much density is distributed from the central tendency towards the end and depict the association or departure or deviance in the distribution. Accordingly, we have to specify the nature of the robustness of our population and associatedness with the awareness of program about the possible quality within the given data set. In a certain more specific and specialized area, we may put coefficient of correlation into a test of Pearson ranking system. We may put regression analysis, analysis of variance, multiple analysis of variance, and sort of things in longitudinal or time scale studies where we try to get a clear picture over interval of shorter period or long periodic studies where a generic understanding of the dynamics and the changes can be reflected in terms of the theoretical orientation. So this sophistication of the descriptive statistics is more refined when you go on development of the interpretive tools for statistics, which help us to look beyond the immediate features of a population and help us to understand the quality within the quantifiers of a sample size. So these things are possible through various kind of statistical procedures which can be replicated and can be reviewed within the available software like statistical package for social sciences, SysStat, Stata, and MATLAB sort of things. In this quantitative journey, it is important to understand by strong associative measurement what we try to achieve. Are we trying to understand the quality of the population, the intensity of the problem, or the procedural robustness? For example, a strong association, if you try to arrive at by manipulation, it actually weakens your overall finding. So it is important to be straightforward and to combine and recombine through trial and error method many types of possibilities, so that within a short period of time you arrive at a very rich profile of your findings. So statistics and quantitative techniques help you to categorize, systematically accumulate robust and useful data, which is also ethically and morally sustainable. As an analytical tool, the strategy of quantitative data analysis is very important and significant array of technique. For example, chi-square test or correlation analysis help you to integrate and understand the dimensions existing between three or more variables which are apparently diverse in nature but have a significant associative leaning. Therefore, these divergent, heterogeneous dynamics of social matrix can easily be reflected when you go on for interpretive statistics like chi-square, regression, or R mode of analysis. All these things are available online in sample form, but you can also generate, if you have an access to the principles of algorithm and how to develop them in a flowchart form, you can generate your own programmable language and a data structure as you want to pursue your case. Once again, here computer enhance your quality of understanding and help you to take a measure of the situation where you are the best judge of your research problems and research questions. So overall, this is a very fascinating area of approach of quality of social life through quantitative techniques. I think it is no more a fear of numericals that will deter you from using computer, rather than the sophistry, ease of use, and attractiveness of presentation will help you to convert your findings in data, chart, diagram, and programmable language. This is a human effort after all, and huge score of mathematical issues are involved in it. What you have to know is how to apply them with the fundamental understanding of quantification in statistics through computer. Quantitative analysis saves energy, space, and repetitiveness. For example, if you take a kind of analysis of students' gender in achieving engineering degree, you may have to also consider the social conditioning and economic features like income, caste, and urban-rural divide. All these things can be neatly and smartly presented if you collect quantitative data in numericals and convert them into a tangible strategy of productive language which computer can understand, store, retrieve, can generate command on that, and therefore it helps you to generate a huge array of colorful graphs, bar grams, pie charts, matrices, which can be easily fit into a very small portion of your thesis, which otherwise may take hundreds of pages with complex sentences and natural language expressions. In this way, you can save energy, resources, and make the presentation attractive and generalizable to a large section of the population in a very easy way. Therefore, it is important, for the sake of resources alone, to adopt a quantitative approach, and it is always beneficial to combine quantity to enhance the quality and in-depth quality of a research question. All these things make your journey more soothing, acceptable, and replicable for retesting, validity, and reliability. Thank you.